A small ball of mass m is thrown upward with velocity u from the ground. The ball experiences resistive force mkv, where v is at. Yeah. Oh, okay. Sorry. My bad. My bad. Okay. It's you say it's v mkv square. Okay. So mkv square. Okay. The maximum height attained by the ball is. See. Let's go back to question number 19 or question number question number 17, right? Yeah, 17. So you see this question is almost similar to question number 17. Okay, a typical application of integral calculus in equations of motion. So just let's first draw the free body diagram and try to understand what's given in the question. So what we need to understand here is, if we approach the free body diagram of the ball here, this is the ball, okay? Weight is acting downwards and the ball is experiencing a resistive force. See, what does this mean? Resistive force will always oppose the motion, right? So the ball is thrown upwards. The ball is thrown upwards. Now, what will the resistive force do? It will oppose the motion, which means it will be acting against the upward direction, which means it will be acting downwards, right? I hope this much makes sense. Now, we have two forces, both of them acting in the opposite direction to that of the net direction of motion. So, what we'll do is, for our convenience, we'll take the all the forces acting to along the direction of motion as positive, and those which are acting against the motion as negative. So it will be negative mg and negative fr, which is negative mkv. Okay. Oh yeah, sorry. So it's mkv square. My bad. So applying Newton's equations of motion, what do we have? Sigma fy is equal to m into ay, right? What is sigma fy? Sum of forces in the y direction. How many forces are there? Two forces are there. What is their magnitude? mg and mkv square. What's the sign? Since both of them are acting against the direction of motion, we'll take both of them to be negative. Therefore, both of them are negative here. Is equal to m into ay. Now, in this equation, I'll divide this complete equation by m. What do I get? M by m is 1, mm is 1. So I'll take negative common, so that becomes g plus kv square is equal to ay. So what is the net acceleration on this body? It is the negative sum of g plus kv square. Okay. Now let's try to bring in one more concept. See, we have used this derivation many a times here, that we said that a is equal to v into dv upon dx, right? Something that we've been using. I think in this set of questions we use it twice. This is third time. So a is equal to v into dv by dx. Now we are considering vertical motion here, so this can be written otherwise as a is equal to ay is equal to v into dv by dy. Now what is ay? We just derived it to be minus of g plus kv square, v into dv by dy. Now look at this. What I'm going to do is I'm going to bring this g plus kv square to the RHS, and I'll keep dy and negative on the LHS. Okay. So it would look something like this. So we have minus, right? Minus and dy kept here on the LHS. I'll take g plus kv square to the RHS. So now in the RHS we have dv and v by g plus kv square. Now a little bit of algebraic manipulations. So we'll focus on multiplying. We'll focus on the denominator. Why? I'll tell you what. So the variable is dv, right? Sorry, v is the variable here. So what is the coefficient of v? Coefficient of v square, it is k. So what I'll do is I'll multiply 2k on the numerator and 2k on the denominator. Why? See, now being a student of JEE means this question shouldn't come into your mind, but if you're from the NEET background, or if you're not, or maybe if you're approaching this for the first time, I would say let's try to understand the substitution in detail. What I have done is I have multiplied this by 2k in the numerator and 2k in the denominator. Why? I'll tell you. See, what is derivative of sorry, what is derivative of g plus kv square? It is actually d by dv of g, which is a constant, plus k into d by dv of v square. We know this value is equal to 0. Why? Because it is a constant, and this what we get is 2k into v. So in the numerator, what we have is v, right? In the numerator, what we have is v. So, okay, to make it more clear, we needed 2k. We need the coefficient to be present along the numerator. The coefficient is 2k. So I multiply the numerator with 2k. So if I multiply the numerator with 2k, I'll have to divide it with 2k, because only then the entire fraction will remain the same, right? Okay. So let's now see what this represents. See, d by dv of g plus kv square is 2kv, right? Which means instead of 2kv, I can write here d by dx of g plus kv square. Okay. And what is in denominator? It is g plus kv square, which means this is actually now of the form. Okay, wait, I missed the dv here. So it's dv here. And now if you integrate on both sides, the integral of the RHS will be of the form integral of f of x g plus kv square into f dash x d by dx of g plus kv square dv, which actually is log f of x, which in this case is log g plus kv square. Okay. Now, since this is based on definite integration, how? Because it is from height h is equal to 0 to h is equal to h max. Okay. What is the velocity at h is equal to 0? Let's say it is va. What is the velocity at b? It is vb. Now, since it is projected from a, we know that va would be equal to u. And any object when thrown upwards, the maximum height, it will be momentarily at rest. It will come to rest for one moment, momentarily at rest, and at that point vb would be equal to 0. So height will vary from 0 to h max, or let us take as capital H, and velocity would vary from u to the maximum velocity is 0. So limit varying from u to 0. Now if we were to do the rest of the calculation, this becomes minus y varying from 0 to h. So instead of minus y, now I can write minus h minus 0 is equal to 1 by 2k times, okay, ln. Now instead of v, we'll have to substitute 0. So this becomes g plus k into 0 square, right, minus ln g plus k into, instead of v, we'll now substitute u, which is u square. Okay. So this is minus h is equal to 1 by 2k whole times k into 0 is 0. So we can write here this is ln g minus ln g plus ku square, right? Now let's make use of this property. What is ln a minus ln b? It is ln a by b. So this becomes minus h is equal to 1 by 2k times ln into g by g plus ku square. Now we can also write one more equation, that ln ab is actually equal to minus ln. So ln a by b is equal to minus ln b by a. Therefore, if I multiply this by entire minus, this becomes h is equal to 1 by 2k into ln. Now using this property, I can write it the other way around. This becomes k u square, g plus ku square by g. Therefore, what is h is equal to? So h is therefore is equal to 1 by 2k into ln. G by g is 1 plus ku square by g. Okay, so yeah, a bit lengthy one. The reason why I made it so elaborate is to make sure that you understand each and every step behind it. Okay. So well, if you get a guess of this, I think you should be able to do the next question on your own, which again is the same concept. Don't go any further. You can use a is equal to dv by dt or a is equal to v into dv by dx, and you can come with the same answer. Okay, maybe a similar kind of application of integral calculus as well. Let's see.